Alrighty, folks. So this is another session for use code coding. Question is find the index of closest number to target number. So let's say all the number are integers, right? That make a symbol. So for example, you have array, for example, size equals 5. And let's say it's assorted, right? You don't worry about that. It's sorted in ascending order. For example, 1, 3, 4, 7, 1, 3, 4, 5, 7. And let's say your target is 6. So given the questions, you want to return index 3, excuse me, because index 3 has a number 5, and which is the closest to target 6. You may ask, what about index 4? Because number 7 is also as close to target as 5. And here, let's say another restriction is if a multiple answer exists, let's return the smallest index, right? Given this situation, you have 5, 7, index 3 or 4, and you want to return the smaller index, which is 3. All right, very simple question. This is a practice coding question for binary search. Clearly, this is binary search questions. So in this video, I want to show people that to implement the binary search with iterative manner. And then in the next video, I'm going to show people how to implement binary search in recursive manner. All right, stay tuned. So we know the precondition for binary search is you have to deal with the numbers in an array that should have a pattern, either ascending order, descending order, or kind of have a pivot. So if you take my class, we have fully explained what kind of pattern you can expect to implement binary search. So it's a rather simple algorithm that is in every round you get rid of half of data by comparing the middle number to the targets. And be careful of when several things, we discussed that, and don't miss any number out of the range, and making sure the algorithm can exit out the while loop. So with that all being said, let's get started with the questions. So I'm just go ahead with the coding because the algorithm should be simple. You see the method header, it's gonna take input array and give you the target. Like I said, is all integer. And this function gonna return a integer that should be the index you want to return. All right, so first you want to check in any corner case. So for example, if array is now, clearly I'm using Java right now, or array length is empty, then this one you can just return special value -1, because -1 never be the index, all right? So that's that. And then the next is just get started on the binary search. Like I said, this is gonna be iterative way to implement the binary search, which is pretty much a common approach to implement binary search on number level. So the basic idea, you have a left, you have right. Physical meaning of left and right includes the left and right boundary of all the numbers where the potential answer exists in that range. That's why there's a binary search. You want to keep narrow down the L and R, so then finally you can land on something that could be the answer. All right. And we talked in the class that there's a certain template. Though I hate using template, but still there's a kind of template to help you to avoid a lot of corner cases. For example, you never can get out the while loop. So I was recommend people taking these simple questions kind of as a practice, reviewing your approach to finish off this question, binary search, in an iterative way. And first, you want to declare the left and right. So, like I said, the physical meaning including the unchecked numbers. And you're gonna get started with the while loop. The physical meaning of this while loop is you want to making sure when you exit out this while loop is right over here. Then you're going to have left plus by 1 equals to right. So that is well, it's a right. Okay, let me clarify this. So that means after exit out the while loop, the answer either could be the left pointer is pointing at or the right pointer is pointing at. So pretty much here you're going to do post checking. So that's a so-called template, right? You're going to take the first while loop to narrow down the left and right, kind of 2 pointers next to each other, and then you're going to go ahead with the post tracking and define, okay, which one going to be the answer. All right, so the logic is you're going to check in the mate, and we talk about that. Please using this to avoid the overflow. So instead of, and be clear, mate equals to left plus right divided by 2. Remember, we declare int 32 bits. If left and right are huge, you may get, overflow. So that's why, based on precedence, you're going to work on the parentheses so that can avoid that situation. So please do that way. All right. And next, you want to check in the mid. So that's pretty much the logic here. So here is if array at the mid, let's say, is less than the target, what you're going to do? So if the mate is pointing some number, for example, here, the mate is at 2, right? 0, 4 divided by 2 is divided by 2 is index 2. So your mate is over here. The number 2 at index 2 is 4. I mean, 4 is less than 6. So pretty much you can get rid of all the numbers ahead of index 2 because they never can be the answer. So pretty much you want to move the left pointer to M. People might be aggressive moving to M plus by 1, which is going to be wrong because you do not know, though 4 is less than target, still possible if 4 could be the answer as closest to target 6, right? So you never know. What about the answer is exactly 5? And if I change in this number as 6, I mean, you're definitely going to return index 2 as the answer. So let me recover. So that's why here you want to change left equals to mid. Hopefully people can follow, right? Then else if, pretty much you see here, I'm having, 3 situations, mid less than target, number at the mid less than target, or what about array mid equals target? So that would be interesting, right? So we're going to discuss very soon. So next one is array mid greater than target. If it is greater than target, I mean, you want to move the right pointer, right? But the same logic apply. You want to move the right pointer to the mid instead of, let me be clear, instead of mid minus by 1. The same reason you might miss that answer. Those greater than target that still could be closer to the target, isn't it? All right. So what about this else? This else is when mid, the number at the mid equals target. For example, we have a lot of 6 because we love 6. And then you see this situation, the mid is at index 2 when L left is 0, right is 4, and the number at the mid is 6, exactly as a target. What would you gonna do? You want to move the right pointer, right? You want to move the right pointer back to the mid. I mean, for this situation, the 1 will be the answer, right? Because the mid is equal target, there's still possibility that ahead of this number, that could be 6 again, right? Or it could be whatever number less or equal 6. It doesn't hurt to move the right pointer back to the mid, right? So with that, you can group the third situation to here, greater or equal to targets. All right. So that pretty much the first part of the so-called template here. So we narrowed down left and right, pointing to next to each other. Clearly, when exit that while loop, left plus by 1 equals right. Now we are entering the post checking. So now this left and right for this situation is going to point into this, right? You want to checking priority, like priority you want to give to the left pointer. So checking if, no, two things. Checking how close, which is closer for number at the left pointer versus the number at the right pointer, reference to the targets. So here's, you want to have an if check. If you can using absolute value, it doesn't hurt. You can go with a math, ABS, absolute, which is array, left minus target. If this one is less or equal to, and math, ABS, again, array right, minus target. I might need to do outside of it. Yes, I am. Have to do. Oh yeah, yeah. Minus target. Well, what will be the answer? The answer gonna be the left. All right. Otherwise, we're gonna return right. All right. So, see, this is a post checking, and one more time is this is the binary search implementation, and we're gonna have first while loop to narrow down the left just next to the right pointers. And the reason we want to have such condition is trying to avoid certain corner cases. We explained it in the class. So that's why don't bother. Just go ahead with this. You don't have to worry a lot of corner cases. And also this can handle certain other instances, not just find the closest number. There's other kind of questions on number level for binary search. So this is all work. So go ahead with it. And after that, after narrow down work has been done, you go ahead checking left pointer, right pointer, see which one gonna be your folk and return. All right, so that's that. And go ahead and check, some user cases. I'm pretty sure this will work. Like already commit that I'm gonna show you guys how to do unit test. So what we do, just stay tuned and subscribe my channel. All right, so for this one, let's quickly check. Let's just using this user cases and see how that works, shall we? So here, do that. I mean, this is the time I'm gonna start with, small talk with you guys, what you guys gonna do, what you guys did last weekend. Look at the time here. So target let's equal 6. All right. So let's try to have objects trying to run that. All right. So let's just print out the answer. Let's call the methods find what that called find the closest, right? Find the closest and array and the target. There you go. So let's run it. Suppose the answer should be what? Should be 1. The reason we explained, because 6 is closest to the target and definitely multiple answer exists. We want to return the smallest index. Alrighty, folks, this is hopefully that makes sense to you guys. This is more into implementation of binary search to resolve one kind of instances, find the index of closest number to the targets. All right, so takeaway, guys, the takeaway for binary search, again, hope you review this portion. Number 1, when you declare left and right, you understand the physical meaning. All right. Number 2, when you deliver the while loop, I recommend it in the class, and now I recommend to the channel people, left plus by 1, left and right to help you avoid certain corner cases. And this while loop is to narrow down left and right pointing next to each other, neighbor to each other. And then you want to do post checking to resolving it. And making sure it can exit out this while loop. That's why we're using such a condition. All right. And third is when you define the mid, making sure you try to avoid the overflow because certain situation left and right are huge numbers. And if you just left plus right, because this is parentheses, take the highest priority, gonna run first, it's gonna overflow. You're gonna have some weird number there. There you go. All right, so hopefully enjoy these sessions. And like I said, next session, next video, I'm gonna talking how to use a recursive way to resolve the same questions. All right, folks, stay tuned and see you next video. Bye-bye.